Have you ever thought of drawing your levels in pixel art first? Then have your game convert that image into a level automatically. It could even do it dynamically on the fly, so you make a change, re-enter the room, and your change has been applied. Well, keep watching and I'll show you how. G'day gamers! In this tutorial, I'll show you how to set up a game to generate levels from images. This is something that is useful because changes are applied to the game instantly, meaning no need to compile the game every time you want to test a level change. You can add instances and tiles or basically anything you like to the level by simply adding it to the image in your favorite graphics program. Personally, I use Sprite, but you can use anything you are comfortable with. So let's get started. Now I've already got a project that's partly set up. I have some sprites for our player and a 16x16 sprite, which we're going to use for our solid. In our objects, I've created a few things here. We have a player object, and the player has the standard movement for HSP and VSP, as well as our standard input and calculate movement, collision, and animation. Now, I'll just drag across our player processor script, and this is how I've set up all of that. There's input, there's calculating our movement, we're checking a jump here, we're doing our collisions, and then we're doing our animation. Now, I'm not going to go into any detail on this because there are plenty of tutorials around for setting up a player. I'm just showing you in case you wanted to pause it and copy anything down. That's how my player is set up. I've also got a begin step, which sets the on-ground variable. And lastly, I'm just drawing the sprite with a sprite extension and setting facing as the image X scale value. Now, that's our player. So I also have an initialization object. And in here, we check in a create event for our OGame, which is going to be where we're creating the level. And it checks if OGame exists. And if it does not, it creates it on the control layer. And the player also gets created. We then move to the next room. Now, OGame and OPlayer are persistent objects, which means they persist between rooms. So they'll only get created once at the start of the game by that initialization object, and you'll see OGame is the same. And they're created in our initialization room. So let's have a look at that. We have a width of 480 and a height of 270, and we also have viewports enabled, and we're using viewport 0 and it's visible. So the camera is 480 by 270, and the viewport is double that, so 960 by 540. So inside of this room, we've dragged across the initialization object, and there it is there. So once that runs, it creates the player and OGame, and then it moves us to the next room. So let's make the next room. I'm going to duplicate this, and we're just going to call it r_game. So now if we double click that to go into it, we want to just remove that initialization object. We don't need that in this room. Now in here, we can also create another layer, and I'm just going to call this collision. And I'm going to change the grid to 16x16 to match what our solid sprite is. So if we go to OSolid, we can draw that here. And just as a bit of a test for our level, we can press play and we should get our player appearing up here, and we can run and jump. So there's our character. Now, let's go and look at OGame, and let's work out how we're going to generate a level from an image. So there's a lot to cover here, so I'm going to move through a little quicker. You might need to pause the video to copy down some of this information. So first I'm going to set a variable called TS, that stands for tile size, and we'll set it to 16. The next thing to do is set our path to our images. Now you can add images as included files. So up here, you can go to included files and you can add them that way. But if you do that, you won't be able to dynamically change them when the game's running. So I like to do it this way because you can edit the images from this path and they'll update the game as it's running. And then at the end, when you're happy with your game and you want to distribute it, you can add them as included files, and then you change the global level path here and it'll update automatically. So the path I'm using is my documents art GameMaker a level from image, and I'm using this capital L because all my images start with that letter. Now you'll also notice that we're using a /, so you need to use that too. Next, we set how many total levels there are. I'm just setting it to 0. And then we're going to calculate how many there actually are based on how many images are in that file path. So we're going to get the number of levels. First, we'll set I to be 0, and then we're going to use a do until. Now, the reason I'm doing this is because we're setting our level variable in here, and then we're using it to see if we still want to loop through this. A do and until will do the check at the end, and that's what I'm after here. So what this check is doing is our levels are going to be in the format of L00.png, and then L01.png, and so forth. But then when we get to 10, it'll be L10.png, and then L11.png, and so forth. So the levels that are under 10 need to be checked, and we need to add this preceding 0. And that's what we're doing here. So we're saying if I is less than 10, then the level is going to equal global level path, which is up here, plus that preceding 0. And then we convert our I into a string. So this would be 00.png. But if level is equal to or greater than 10, we then don't add this preceding 0. And we just create the path of this with our number.png. And then we add to I to do the next one. And we'll stay within this loop while the file still exists. When it doesn't exist, we jump out. Our I will be 1 greater than the number of levels. So in that case, we can take 1 away from I, and that'll equal the number of levels. And lastly, I'm just setting our current level to be 0. So now we know how many images we need to process, and we can then process them during the room start event. So let's add a other room start. And here I'm going to run a script called build room, which will basically build the room. Now I'm adding it to a script because we want to be able to use this from anywhere. When certain things happen in our game, we can just build room if we need to. Say, for example, the player moving out of the room, we want to be able to build the next room. So let's make a new script, and I'm going to call this game processes. And let's go to our game, just drag this in. And we don't need this, but we do need our function for our build room. So I'm just going to make this big, and then we can see it a bit easier. Now, the first thing we want to do is delete any OSolid objects that were there from the previous build. So we'll delete our old instances. Basically, we can just do a with OSolid and an instance destroy. Now, in order to read the colors off an image, we're going to add that image to a surface. Now, when you run GameMaker, it draws all of the graphics to a surface. It's called the application surface. But we can create other surfaces and draw to those instead. So I'm going to set a local variable and set it to be surf and just set it to -1. So the next thing to do is to get our room map. So we want to get the room map. And basically that's just going to be what we did in the create event. We want to take a copy of all of this and paste that in. But instead of I, we're actually doing it as global.currentLevel. So we're looking at our current level. I'll take a copy of that and just paste that where we have our I. So we're looking for our current level, and we're setting our level to be the path and the 0, whatever level we're at, and a PNG. So this will do just what it did in the create event for us. And once we have that, we can actually get the sprite data. So we're going to read that file in as a new sprite. So var, say sprite is called sprite_add, and you can add sprites on the fly with this function. Now it's just level, and then the rest of the information here is actually going to be a 1 for the image number, and then all of zeros here, so 4 zeros. Now we're going to need the width and the height of the sprite, so we're going to store that in W, and we're going to use sprite get width of our SPR, and for the next one we got our H, and this time we're doing sprite get height of SPR. Now that we have our sprite data, we can set our surface up. So our surf is going to equal surface create. And we need a width and a height for that. So it is our W and our H. Now that we have our surface, we can draw that sprite to the surface. So draw sprite to the surface. And we can do that by saying surface set target. So we're setting where we're drawing, and we're drawing to our surface. And now I'm going to do a draw clear alpha, and that will just clear the surface to make sure there's nothing on it. Now we'll draw our sprite, and it's SPR. Our subimage is 0, and just drawing it at 0, 0, which is the top left. Now that we've drawn it, we can reset our target for our surface. So surface reset target, and that will just enable us to then draw to the application surface again. And lastly, we don't need that sprite anymore, so we need to delete it so we don't end up having it hanging around in memory. And we'll delete SPR. Now, once we have that surface, we can then read that surface into a buffer, and we can then read each individual pixel and work out what we want to do with it. So here, let's convert the surface to a buffer. Now, a buffer is just a part of memory. And the reason we're using them is they're extremely fast to read and write to. So if we put our image into a buffer, it's very fast for us to read and write the information we need. So we're going to say var underscore buff equals buffer create. When we create the buffer, we need to put a size. The size is going to be 4 times underscore W times underscore H. And the reason it is because we need this amount of information because we're storing an R, a G, a B, and an A. So a red, a green, a blue, and an alpha for each pixel. So we're allocating space for that read. Now the type is going to be buffer fixed, and our alignment is just 1. Now the exact details of all the buffer and explaining and understanding buffers is not really needed for this example. It's a quicker way of doing it. It's why I'm using it, but you don't need to fully understand how they work in order to use it in this example. So don't worry if you're thinking, oh, this looks a bit complicated. The amount of work here with buffers is just a few lines, and the result is a much faster way of doing this. Now, the reason I mention this is because there is another built-in method within Gamemaker of doing this, and it's called surface underscore get pixel. Now, the problem with this function, though, is it's very slow. And if you have many rooms and you're doing this with, it can be a little slow for it to process. So the method of using buffers is actually much quicker. Hence why I'm showing it to you, because I think it's the best method to use. So now that we have our buffer, I'm going to say buffer get surface. And we're going to move that surface into our buffer. Now our buffer is just called underscore buff. Our surface is called underscore surf. And the offset is going to be a 0. Now we don't need that surface anymore. And when you finish using a surface, you need to free it. So surface underscore free underscore surf. And that will just make sure we don't have a memory leak. So now that we have our image inside a buffer, we can look at each pixel in turn and work out what color it is, and then do what we need to do with that color. So in order to loop through our image, we need to go through every pixel. So let's set up a for loop here. So we'll say for var underscore y is equal to 0, underscore y is less than underscore h, and plus plus to y. So that will loop us through the height, and then we need to duplicate that. And this time we're going to move through the x, and it's going to be up to underscore w. So essentially that double for loop will actually move us through every pixel on the map. Now we can use those values to then read the buffer position and then for read the color. So if we do a buffer seek, we can look at our buffer, which is underscore buff. Now we need to look at where we're starting this, and it's going to be at buffer seek start. And the offset is how far along we need to look at. Now each pixel has 4 components that we're interested in: red, green, blue, and the alpha. I'm going to grab the alpha, but we really don't need to use that in this example. But the offset to enable us to do this is going to be 4 times, open brackets, underscore x plus underscore y times underscore w. Now that offset will just make sure that we're looking at the right pixel. So what buffer seek will enable us to do is read a memory location, and then the next time we do a read, it'll shift by that offset value. So what we now want to do is store our R to be buffer read of our buffer, and we're storing it as a buffer underscore U8. Now that may seem quite complicated, but to be honest, you don't need to understand what's happening to just see that we're reading the pixel of the image at each point, and we're storing the colors into these variables. And that's essentially all you should be trying to take out of it. So here we're storing our red, and then our green, and then our blue. And lastly, I will save the alpha, even though we're not going to be using that in this example. So now once we have those values, we can combine them to find a color that then we can reference. So var color is equal to make color RGB using red, green, and blue. And that will then convert it into a color that we can reference that Gamemaker knows. Now with that color, we can run a switch statement on color. And here's where we can tell Gamemaker what to do when it finds which particular color. Now at this point that we need a map file. This is the time when we need to go into our graphics program and work out, well, what's our map look like that we're trying to read? So here's one I've already prepared. So this file is 30 by 17, so it's very small, but those dimensions match what's happening in the project in relation to the room size. So if you're going to do this and follow along, you need to make it the same size. So that's 30 by 17. Now the colors I have here, this is my solid color, and that's the hex value for it. But in our example, we're not using the actual hex value. We need to convert that into Gamemaker's GML raw format. So if you take a copy of this value, and then I like to use this color picker, which I'll leave a link in the description of how to get to it. You can actually paste in a hex value here, and it'll give you the Gamemaker raw value down here. So if I take a copy of that, go back here, and we can then add a case for that value. So if the pixel we're reading is what we want to have as a solid, then we want to create a solid at this position. So this is our solid walls, and we can just say that we want to do instance create layer, and it's going to be at our X times our tile size and our Y times our tile size. And we want to put it under the collisions layer, and we want to create an O solid object. So that'll simply create our walls when it finds that pixel. Now back in our image, if I look at this color, the green, and take a copy of that, go back to our tool for color picking and paste that in, then we end up with a value that we can take a copy of. And now here we can have a case for this color, which will be to position the player. Don't forget to add your break there at the end of the switch. And we can just say, oh, player.x is equal to whatever the underscore x position is times by our TS. Now I'm also going to add TS divided by 2. And that's because that will then position the player in the middle of that square in the horizontal direction. So let's duplicate that and let's put it for Y. And for Y though, I'm just going to add TS, and that's because my origin position for the player is at the bottom. And being that the player is 32 by 32, this will move it down 16, and that'll position it right where it needs to be. So lastly, when we're using a buffer, we need to clean up at the end. So this is a cleanup, and we need to make sure we say buffer delete of our underscore buff. So you might notice here that we're referring to A. We're not actually using that, so I'm going to comment that out, but it's handy to know that you can read the alpha in that way as well. And lastly, I think this is called collision and not collisions. So let's just change that. Now let's press play and we'll test that out. Great. So there we have our level just as it is in our image. So all the old solids got deleted and they got added correctly. So how do we move to another room and another level? Well, when the player moves outside of the room to the right, then we want to build another room based on the current level we're in +1. So there's a few things we need to change for that to work. Firstly, I'm going to go here to our build room and I'm going to add a pass variable called inish. Basically, that's a variable saying, is this the first time we're into the room? Do we need to initialize the game from the start? And the reason I'm saying that is that we will use that here. And we'll say if inish, then we want to position the player on that green pixel. Because when we move to a new room, we don't want to position the player on a pixel. We want it to just be smooth between the transition of the rooms. So therefore, in our room start, when the room starts, our initial is going to be true. So we're passing the true variable to our build room, and inish is going to be set to true. So therefore, the player will be positioned correctly the first time the game starts. Now let's have a look at our player. And let's add a new script here called check room. And we can use this to check if we want to move to another room. So let's bring our player processes up here, go to the bottom, and let's add a function for check room. So when we move to a new room, we're checking to see if we've moved our X position bigger than the room width. So if X is greater than the room width, well then we want to move to the next room. Or stop the player if we're at the room edge, because there might not be any more rooms to move to. So we should check that and say if global.current level is less than our global.levels -1. So then we can use a script and say, well, let's move to the next room. And we can pass that initialization variable. In this case, it's going to be false because we're not starting the game. So else, if that's not the case, then that means we're at the last level of the game. We don't want to do anything. We'll just block the player from moving out of the room. So we'll say X equals room width. And that way it'll stop them running out of the room. So what happens if we move to the left? If we're not going to the right here, and we want to move to the left and go to a previous room. Well, then we could say else if X is less than 0, then we can say previous room false, because we're going to a previous room. And once again, we don't want to set that initialization to be true. We're just running to the next room. We want to move and load that level. So we need next room and previous room set up as functions. I'm going to do that in the game processor script. So we have a function for our next room, and we're passing our initialization in. So if we're moving to the next room, we're adding one to our global.current level. And we want to make sure we limit the level. Let's just get some space here. Limit the level, so we can say if global.current level is greater than or equal to global.levels. So if we're trying to go to a level that's bigger than our current levels, then global.current level is equal to global.levels -1. So that'll ensure we can't go to anywhere that's bigger than our current room. So now let's build the room. So let's say build room. And what are we passing for our initialization? Well, it's what we've passed above. And lastly, we need to position the player, because if we didn't move the player with the initialization, we actually need to move it here. So if not initial, then oplayer.x is equal to 0. And the reason we do that is because if we're moving to the next room, so you can imagine the player has moved here they've touched the edge and moved to the next room. Therefore, we need to position the player over here in anticipation for the next room. So that's why we're setting to 0. So that's our next room. Now let's do our function for our previous room. Same thing, we're doing passing our initialization. And we're saying global.current level minus minus. Once again, we want to limit level. And we can say that if global.current level is less than 0, then global.current level is equal to 0. And that'll save us going to a level below 0. So now we can build the room. So we say build room and pass our initialization variable. And once again, we want to position the player, same as we did before. We can say if not init, then oplayer.x equals, and this time we want to equal the room width. And it's the same concept as before. If we're moving to the left, therefore our room's going to load as the previous room, we want to be over here to start that room in the correct position. So we want to be at the room width. Now, the only other thing you'll need to do is have a second level created. So if you remember, this is my path for my levels. If I go in here and I've saved this into that path, I actually have a second level already, but you can draw your own and you can use any colors you like. But like I said, you need to grab the hex value and then convert it to a GML value. So I already have 2 levels here. Back in the game, if I run this, I should get the second level working. So we have our player, we can jump up here, move to the edge, and we move straight to the next level. And you get an instant transition even when you jump through. Using the buffers there, it's very quick to load between the levels. Now, if you've got 2 levels and you did the surface get pixel method, you'll find it's quick as well. But later on, if you're doing a lot more calls of that function, you'll get a lot more slowdown. Now, the next thing is, how do we get all the tiles working? Well, let's have a quick look at that. So back in our game processes, in our build room, let's create some tile sets that we can then bring in the same way. So back under our game, I'm just going to go here and we'll just create some tile sets here. I'm going to call this one tiles_background. And then I'm going to have a tiles_border and a tiles_solid. Now, under our assets, we want to create some new sprites here. And this one's going to be s_tiles_solid. Now, for our tile set, I'm going to use a 16x16 tile set, but the image needs to be, take this tick off, needs to be 32 wide by 16. And that's because the first one needs to be blank and the next one is where you can start drawing your images. So I already have some tiles that I'm going to use. So I'm just going to import my tiles. So as I say, the first one's blank and then you've got your tile here on the right. And these are going to be what I'm going to use for the solids that the player can jump on. So I'm going to duplicate that. And this time it's a tiles border. Double click that to open it and import again. And I've got a tile for the border. And that's just around the outside. And I'm going to duplicate that. And the other one's just going to be tiles background. And import, and I've got a background image as well. It's like a dark image. So what I'm referring to is this area here is the border, and this area here is the background. So I need to create tile sets for these. So right click, create tile set. I'm just going to have it called t_solid and select the sprite for the solid. And 16x16 should be correct. Make a new one, create tile set, and it's going to be t_border. Select that border. And lastly, I've got a t_background. Okay, so now that we've set that up, we go back to our code and we've got our solid, our border, and our background tile sets. We need to make sure that the tile sets are assigned. So under the solid, you want to set solid. Under border, set the border, and background, we'll just set the background. So back in our code. So the first thing I want to do, because we're going to be manipulating those tile sets, we need to grab the ID of them. So I'm going to set a variable called global.solidMap, and we're setting that to the layer tile map get ID of our tiles underscore solid. Now I'm going to duplicate that twice, and this time we're going to have our border map and our background map. And here we're after our border and our background. So make sure your spelling is correct on these. It doesn't check this. So now that we have our maps, we're deleting the old instances of those solid. We also need to delete the old tile set if we've drawn from a previous level. So we want to reset all tile layers. And we can do that just by saying tile map underscore clear of global.solidMap. And what do we want to set it to? Well, 0 will clear them all. So let's duplicate that, and we'll set the border map to be 0 and the background map as well. So now that we have our tile sets all set up, down here where we're setting our solid, we also want to draw the tile of the wall. So tile map set, and we're setting global.solidMap to be 1, because that's the tile that we want to use. The first position on a tile map is 0, and the next position is 1, and that's where our solid is. If you have more tiles, you could change this value and set it to the tile position in that tile map. But for me, for the example, we're just using 1. So X and underscore Y is our position to set it. Now, we also want another case, and that's for our border. So back here, if we look at our border graphic, it's this one here. If I click on this, take a copy of that, go to our tool and paste it in. I can get the raw value here. So take a copy of that. We'll go back here and we'll paste that in. And this is our border tile. So I'll take a copy of that tile map set, because that's the same thing we're doing, except we're not setting the solid color. We're setting the border map. And we'll just set it to 1 again. So we need to add a break there. And let's duplicate this case, Control D. And we need a color for our background tile. And we're not setting border map, we're setting our background map. So we just need this color. If we go back here and I hold down Alt, click on the color, I can get it here. So we'll take a copy of that, go back to our tool and paste it in. And then this is the raw value that we have to take a copy of and paste in here. So now we're setting the maps of the tiles. We should be able to run that, and we should get the new graphics appearing in our game. And there we go. So that looks much different. And we get the new ones appearing. So we never tested this, but if we go to the end of the room here, we shouldn't be able to move beyond that position because we have no more levels. Now, if I run that as it is, and I then go back to our image here, I can add some platforms or anything at all we like. And if I click save, when we go back to our game, they don't appear straight away. But if I walk out and come back in, the new changes are instantly there. And I didn't restart Gamemaker. They were just there because they get applied when we move to a new room. It reads the image file dynamically. So that's really handy for making changes. You could add enemies or anything you like, and they will appear when you come back into the level. So if you want to do some testing, we have these very handy functions, next room and previous room. If you go to your O game and say if you add a key press, let's just use the keypad and make it the plus. You could run next room, and whether you want to run the initialization, so we'll just say false, And we can also add a key pressed for minus. And we can say previous room, false. And now when we run that, we can use plus or minus to move between the rooms. So if you're doing some testing, you can quickly press plus or minus and it'll take you to the position. Now you'll see that the player is placed there. So you might want them to appear as they walked into the room or at the start. And that's why we have the extra green on all the levels. So if you remember, we have a green here and this one has a green. So instead of setting it to false, you can set it to true. And the initialization will take place and that green will place the player in the correct position. So if I press plus, then we're in the correct position where the green is, and minus for the same. So if you've got lots of rooms, you can easily press plus and minus, and you can zoom around between the rooms to test them out. Of course, you wouldn't leave that in the final game, but for your debugging system, it's a really quick way to move between your rooms. Now, lastly, what I want to talk about is the method I've shown here is a little inefficient because we are creating multiple OSolid instances that are all 16 by 16 in size. So if your room ends up being quite big, you would have a lot of instances that we're using for the collisions. A better method would be to not use objects for collision, but instead to use tiles. Now I have a course that teaches you how to set up your player character for tile collisions, and that would be a much more efficient method of utilizing this system. The course is called How to Make a Tile-Based Platformer in Gamemaker, and it is currently the highest rated Gamemaker 2 course on Udemy. So if that's something you're interested in, there is a coupon in the description to get you 90% off the retail price. I'll make the source code for this tutorial available over on the Patreon site. My Patreons help me to make content by supporting the channel, and this month I'd like to thank these legendary Patreons: Dylan Jackson, Kazaho, Andy K, Emre Kos, and Tom Frakey. Their generosity helps me to continue to put out free content for you. Also, thank you to these epic Patreon members for their generosity too: Skydevil Palm, Sheldon ENTP, Salvatore Capolino, Dan Half, El Delapesi, and Gresna. Lastly, thank you to these rare supporters of the channel as well. If you are a Patreon and you contribute $20 over time, I'll send you a copy of my tile-based moving platform engine, which you can use as a basis for making your own games. It's available on the itch.io store if you want to check it out. Now lastly, that image of the little player character, that was not drawn by me. It was drawn by a very talented person over on itch.io. I'll leave a link in the description to that image. It's free to use if you'd like to have a look at it. So that's all for this tutorial. Thanks for joining me. I'll talk to you in the next one.